going to talk to us about the Lost Art of Telidon, a combination of digital art preservation and software preservation. So John can explain and talk better than I can, so I'm going to let him do so. Thank you, John.
Thank you all. And let me know if I'm mumbling in the wrong side of a microphone or something like that. Yeah, so as Mike said, I'm from the University of Victoria. I'm going to talk for the next 45 minutes-ish or so about a series of projects I've been working on to restore some old Videotex artworks that made their way into our archives a few years ago, and then kind of going on from there. So specifically, I'm going to be talking about artworks made using technologies that originated out of Telidon, which was a project of the Canadian federal government in partnership with a number of industries to create Videotex networks back in the early 1980s. The artworks that I'm going to be mostly focusing on were long thought to be lost, kind of victims of technological obsolescence. Where the files still existed, they were thought to be unrenderable because of the absence of the hardware that was used to create and display them. But over the last 4 or 5 years, a number of projects have been kind of underway to address that and to bring these things back. And a number of artworks have surfaced in the collections of the University of Victoria archives, the Artex archives in Montreal. There's an artist makerspace called Interaccess in Toronto, and the private collections of the artists themselves. So there's a fair amount of this stuff out there, but the question is how to bring it back in some kind of coherent way. I'll be covering 4 projects in 2 parts. The first half of the talk will be about work that I've done to restore the works of a Victoria-based artist named Glenn Howarth. Made a bunch of Telidon stuff back in the early 80s. And then the second part of the talk are a couple more projects that are more recent, relating to an initiative to kind of scale up on a national level and restore as much Telidon art as can be located. So, part 1. So I first encountered Telidon art back in 2015, and actually at this point I'm just going to break. How many people have actually heard of Telidon before this talk? Cool, that's more than I usually get. That's
I'm from
3.
Canada.
Fair enough. I'm from Canada too. I hadn't actually heard of this until about 2015. I've been a library technologist for about 20 years now, and it kind of shows how far into obscurity Telidon slid after its sort of peak in the mid-1980s. But we're going to talk a little bit more about that as we go along. So my involvement was basically I was called into a meeting with our university archivist and our director of our art gallery. We were planning a retrospective on this Glenn Howarth guy. They were interested in tracking down some of his digital art. He'd been a well-known Victoria painter mostly. He passed away in 2009, and in 2012, about 10 banker's boxes full of his stuff was collected into our archives. And it was known that he'd done this digital art, but very little else was known about it. He had exhibited across the country and as far afield as the Sao Paulo Biennale in 1983, where he co-curated an exhibit of 11 Telidon artists that was kind of on display for about 2 months at this relatively prestigious international arts exhibition. So it was probably in some ways the peak of his international recognition. So it was an important part of his career. But again, we didn't know more than that. One of the banker's boxes in his donation included about 200 floppy disks, and we kind of thought that maybe some of his computer art might be on those. We hadn't actually done a real inventory of the disks at this point, so we weren't sure. A few of the discs, the boxes and the disc labels, as I was going through them, had words like Telidon and Netflix written on them, and Googling that kind of provided me with a bit of useful contextual background, which I'm going to summarize briefly here. Telidon was one variant of a technology called Videotex. Now, it was here. You can see it featured on the cover of July 1983 Byte magazine. Back in the 70s and through the early part of the 1980s, there were a variety of international efforts to create mass-market interactive telecommunications networks. The idea was to create computer-based information systems that people could access through their home, in their homes, with a decoder box on top of their television set, and a little two-way communication through a punch pad, keypad, that's what we call them, and often connecting via phone line to call down information relating to, the kinds of things you might expect, right? Weather, sports scores, flight information, maybe some online shopping. There were a variety, even banking was actually being thought about as a use for Videotex networks. Security issues might have been a little bit, something that had to be worked out. But, you get the idea. It's sort of like the web, in fact, but a lot clunkier, a lot more centralized, and a lot more kind of with very designated content providers. Could be implemented in a variety of ways, but on the using end, it often involved, as I mentioned, a Videotex decoder box hooked up to a television set with a modem cable and a little punch pad, as we see there. Telidon was Canadian, not so much because it was, just because it was located in Canada. Most of its technology stack, in fact, was developed in Canada. By the Canadian federal government, the Communications Research Centre, and in partnership with Canadian industries like Norpac and Electrohome. So, in particular, it used a data encoding format that was developed by the Communications Research Centre of the Federal Department of Communications. And it went through a couple of different versions, and in its second version, it became an international standard. This was after companies like AT&T got involved. Became an international standard for Videotex called NAPLIPS, which was initialism, I guess, for the North American Presentation Level Protocol Syntax. I don't actually think marketing was involved in that one at all. This slide, by the way, shows the CRC research team that developed Telidon. It's bound down in the lower corner there. They're gathered around an early Telidon system, so you can actually see the TV and decoder box and like that. So, just to clarify, hopefully, you can think of NAPLIPS as a kind of a file format. It's not exactly a file format, but it's a way of encoding images, and very heavily optimized for the limited storage and limited bandwidth capacity of the late 70s and early 1980s. It was a vector encoding format, so it was capable of encoding far more sophisticated graphics than its competitors, which were typically more of a kind of bitmapped kind of approach. So, it was thought in a way that this was going to make the emerging Canadian technology kind of poised for world domination in the new Videotex marketplace that was sure to sweep the world. The feds put in many millions of dollars in seed funding to get Videotex networks off the ground. But by 1985, it was evident that most of these projects, which had been trialed through various field trials and so on, were not going to become self-sustaining anytime soon, and the federal funding was pulled in 1985. It was a change in government at that time as well. So basically, March 1985 is when Telidon ended. Although NAPLIPS itself continued on for a while after that and probably achieved its peak adoption as the graphics subsystem for the old Prodigy online service back in the late 80s, early 90s. During its brief heyday, however, it created a lot of excitement, and a lot of people really got involved with Telidon one way or another. They included people like educators who were interested in the pedagogical uses of it. They were interested in use of corporations, obviously, trying to figure out ways that they could monetize it. and artists who were actually just kind of interested in the artistic potential of this new and exciting medium. Central here was a collective called Toronto Community Videotex, which was an artist-run collective that was very central to the production of Telidon art in Canada. They were profiled here in this 1984 article from the Globe and Mail. We'll get back to them in a bit, but meanwhile, back at the ranch, the University of Victoria was also something of a center for Telidon art production as well. There were two people who were very centrally involved at UVic. One was Dr. David Godfrey. He was a very well-known Canadian author. His CV is actually kind of impressive. After he won the Governor General's Award for Best Novel and founded a couple of really famous publishing houses, he sort of veered into software. He started a company called Softwords, where he was interested in exploring Telidon and what kind of uses it might have, and just educational technologies in general. He was also the author, co-editor, publisher of a book called Gutenberg II, which was a really influential book on the early history, or the sort of early speculations around the sociological impacts of computer networks. Along with him, there was another guy named Dr. Ernest Chang, and Dr. Chang's project was to create a low-cost Telidon content creation terminal. So Glenn Howarth met both of these folks in the summer of 1981, I think, when he was teaching a painting course at UVic, and that's where he really started getting into digital art. And in fact, he was sponsored and encouraged in his shift from painting into digital art by both of these people in a couple of different ways. Back then, you really needed sponsorship or some kind of access to university facilities if you wanted to create this stuff. The technologies for creating content for Telidon networks were not, something you just sort of walk down to your local computer store, there were computer stores in 1981, and buy off the shelf, right? This was a fairly high-end stuff. This was a NORPAC content creation terminal here. It was cost about $25,000 in 1980s dollars, and it was built around a DEC LSI 11, I think. So not trivial to be able to make Telidon content. That said, Glenn Howarth's setup was in fact not quite as fancy as the NORPAC unit I just showed you. As I mentioned, Dr. Chang was working on a project to create a low-cost Telidon content creation station, and he based his on an Apple II, and that was the system that Glenn Howarth used to create his artworks. This was never commercialized, it was always sort of a prototype, and Howarth essentially became part of the development team, giving feedback to the developers as they built the software. So he was creating his images as the system he was using was developing. So it's kind of an interesting little feature there. So I'm going to be talking about these projects in the order that I did them. So that means I'm going to be talking about a project to restore second generation Telidon before I get to the first generation stuff. It's actually better just in terms of how as a sort of an introduction to some of the challenges here. So digging through Howarth's floppies, I came across some disks that looked to me like they probably contain images. There are a couple of clues there I won't go into, but one of the interesting things about it is this is a partial directory listing for a disk that contains something like 80 images. It's a 360K floppy and it's got lots of space left over. So you can sort of get the sense of just how compact these things were, right? You think that an image that comes out of your iPhone is what, 2 megabytes or something like that? And, this is a 1/6 that size, and we've got 80 images on it. So when I opened up the files in a text editor, I saw that lo and behold, they contained ASCII text. For the most part, it was not readable ASCII text, although even if you look carefully, you can see a couple of readable words in there. One of the interesting things about Naplix was that we put in an ASCII encoding in a sense. Although the significance of Naplix was at the bit level, all of the bytes in a Naplix encoding were encoded as ASCII. So, and this was to facilitate transmission between different systems, because of course it was a lot easier to transmit ASCII between different systems back then. And in fact, as I think I understand, if you wanted to transmit binary, it was typically there were programs that would convert binary into ASCII, you transfer it, and then convert it back into binary. Correct me if I'm misrepresenting any of this stuff, but Naplix essentially obviated the whole conversion step by just being encoded in ASCII to begin with. I'll go into a little bit more detail about it later in the presentation. So now that I had some files to work with, I was a little bit uncertain as to how I was going to actually render them as images. I didn't have any of the software that Len Howarth used to create or display his images. I had some disks that looked like they might have contained that software, but they were unreadable. I don't normally give the reason why they were unreadable, but for this crowd I will. They were in the PC version of the UCSDP system, which is really hard to read. It uses a sector encoding format that's like that's sort of like copy protection almost. It's odd stuff. So anyway, we needed to find some alternative software capable of rendering Naplix graphics, so I looked around, and the nice thing about Naplix is it's really, really easy to Google, right? It's Naplix, and there's lots of stuff. It's all relevant. And so it didn't take me too long to track down some alternative software in the Simtel DOS archive, the venerable piece of computing history that is not maintained anymore, but there's mirrors of it all over, including Jason Scott's pexfiles.com, a huge trove of pre-web net culture. In particular, that's where I found Personality Plus 3, which is created as a bulletin board client system created over several versions by a company called Microstar, based in Ottawa. And it had excellent support for Naplix graphics. So this is a short video capture, actually, of me opening one of Howard's graphics in Personality Plus 3. The short pause in the middle while I haltingly enter the file name and press a couple of keyboard commands to get into Naplix mode. Okay, so that was a good start, but there was a problem. As I've been doing the research on this project, I came across people who had, of course, actually seen these works. And maybe I should back up at this point and just say, I didn't know at this point what these works were supposed to look like. I didn't have any objective reference to sort of point to say, yes, this is an authoritative version of this work that I'm trying to recreate. So, but I was able to talk to people who'd seen these works. Obviously, the author, the artist, was passed away, but there were people who are still around who'd seen them when they were new. There were also some writings in the archive that suggested that, in fact, the speed of rendering is really, really important. And in fact, what I was seeing was rendering way too quickly, right? The idea is that these things should sort of gradually assemble themselves, and you should see them in the process of drawing and so forth. And that was like a really, really critical aspect of the work to the artist. I should say that's nothing about that in the Naplix or Telidon spec. There's nothing about how quickly the image should render as part of the spec. So what you just saw was completely standards compliant. It was just wrong. Fortunately, there were other people who were smarter than me who've had similar problems, so DOSBox to the rescue, right? It's possible to use emulation to slow down the emulated processor speed to introduce delays into your representation. DOSBox is not perfect, it's not cycle accurate, but at the same time, there's a big question around what perfect even means in this context, right? Because we're not talking about trying to emulate a specific system doing a specific thing. Naplix was a generic protocol that could be implemented by many manufacturers and on many different systems, and they all had their sort of differences in how they were implemented. So, basically, that's my excuse. This is the same image rendering in 400 cycles, DOS box setting. And I think you can see it's quite a different experience of the image as these vines and things kind of grow up and more of a sense of that they were actually sort of growing. Something else about an applets is there's nothing in the protocol, I think, that says which direction the shape's drawing from. So in fact, in theory, they could have been drawing in from the bottom, or drawing in from top to bottom, which would have kind of made it look a bit weird. But luckily, that wasn't how this particular decoder decided to do things. So great, that was off to a good start. Telidon 699 is the first generation of Telidon, and so we'll be talking a little bit about that now. And that's things were this required a bit of a different solution than the first one. So as I worked through some more floppies in the box, I came across a whole bunch of Apple disks. The other ones have been DOS, but this was Apple, containing hundreds more images and the software that Howard was using at the time. So this was great, probably fairly straightforward. Software ran an Apple II emulator, but it only showed me a list of the files that it was thought it was displaying. It didn't actually display the files. And of course, it should have been obvious that the software was not built to output the images to an Apple II monitor, which would have been too primitive to handle them anyways. It was built to output the graphics over a serial connection to an attached decoder, which would then represent the graphics on a television or more sophisticated color monitor. This was an example of one of the decoders that might have been used to do that. The problem here is that accurately representing this first generation Telidon artworks is a little bit more challenging because there's no software that was actually ever written that could do that. It was all done in hardware. And I don't know if you've looked, but eBay is not exactly littered with used Telidon decoders. There weren't a lot of them made. I think the height of the BC field trials, there were something like 250 of them in the province. And so they're pretty hard to track down now. So, this is just an example of you try to run first generation Telidon graphics through an Applets decoder, and it just looks like that. Kind of pretty, but in an abstract way, but not really what Howard had in mind. We're pretty sure. So I was kind of thinking this might be as far as we could go, but. In September 2015, I came across this note from Brent Hilbert on the Classic Computers mailing list. The important part of this was the Radio Museum here in Vancouver, Canada, has a color Videotex terminal with integrated CRT made by Microtel. It's in danger of being thrown out and needs to find a desiring home. So I sent an email to Brent asking about the terminal, and he said, yeah, it's still there, and he checked it out and it worked. So he was interested to hear that I had some original content, so we agreed to meet up at the museum and run them through the decoder. So October 2015, I made a trip over to the Spark Radio Museum, which turns out to be in Coquitlam, not in Vancouver, but it's close to Vancouver. Specifically, it's located on the grounds of the old Riverview Psychiatric Hospital. It was shut down a few years ago. It's a great film. It was one of the filming locations for the X-Files TV series, because they may have seen it in that context. The Scarborough Museum itself is not one of the creepy old crumbling Edwardian buildings. It's actually just a metal warehouse on the back of the grounds that they share with the BC Ambulance Service. It's a volunteer effort, mostly a workshop and clubhouse for a group of radio hobbyists, the Society for the Preservation of Antique Radio in Canada, or SPARC. I was kind of blown away by their collection. Veering a little off topic here, but if you ever get a chance, if you ever find yourself in Coquitlam on a Sunday between 10 and 4, you should definitely check this out, because it's just got this is 1/4 of a much larger space, and it's just basically all like this. It's filled with radios and memorabilia, and it's just a brilliant collection. We've got a lot of historic stuff. Most of it still works. So Brent set up the Microtel decoder in the workshop, and you can see, unlike the unit that I showed you before, this one does have a built-in CRT. Here's a bad video shot on my iPhone of an image of Howard's rendering on the decoder, and this was a great sort of culminating moment. It was great to actually see original Telidon art rendered on the technology that was meant to be rendered on. So that was quite neat. Spark folks were very kind and let me take the decoder back to the University of Victoria in January 2016. They're so kind, in fact, that I still have it on loan 3 years later. I do ask them periodically whether they want it back. But anyhow, very kind of them. I spent a week in February getting Howard's images ready to go. I had to write some scripts to send the images to the decoder in the correct sequence. And then we did a really kind of old school recording where we pointed a video camera at the CRT. Part of the reason is that I'm not a supremely high-tech person when it comes to hardware. And also, I didn't want to tamper too much with a device that was, from another organization. So, and on my defense, this is the way many Telidon artists back in the 1980s recorded their works as well. So, it has a sort of purity of authenticity, if you like. So, this is a sample of the end product. A sequence called Vegetarian Nightmare. There's a bit of a story behind this one. Basically, Howard was a lifelong vegetarian, and he went to a reception dinner, and they made him eat steak, and he had nightmares for a week. So this was a sequence that he did, exploring some of the sort of horrific, nightmarish imagery that he was having visited upon him. It's been too long looking at this. So kind of surreal. He was an interesting guy for sure. So the show, we had the show well received. It went on for 6 months in Victoria, and that could have been the end of my involvement. But during my research, I've become aware that there was probably a lot more Videotex art out there across Canada, and so I kind of thought, I should really bring this stuff back, right? Like it's like now's probably the opportunity. We don't want to wait for too much longer. If we're going to get this stuff back, we should do it now. And specifically, I come across a site called the Dead Media Project. It was a project by Bruce Sterling and his friend Richard Cadry to catalog dead media, so things like the Teleharmonium and the Stereoopticon, and there was actually an entry for Telidon on the site, supplied by the artist Jeffrey Shea, basically saying, the artworks still exist, but as far as I know, there isn't any way to actually view them. So, it's they can't be seen. Their interactivity can't be experienced. So the medium is dead. This site dates from about 2000, so this was about 15 years after the peak of Telidon. Already people were thinking, you just can't do anything with it, it's gone. So I wrote to Jeffrey and asked if his discs were still available, and they were. Turned out they were 5 1/4-inch discs in Naplip, so that was pretty easy to do. And so what came out of that that's when I became aware of Toronto Community Videotex. Jeffrey, along with 2 other people, Will Perry and Nina Beveridge, were the founders of an artist-run cooperative, which was a hotbed for the Telidon art production back in the early mid-'80s. Can't give you too much more background. There's a great motherboard documentary that came out a few years ago on them, so I think it's still online. You can look that up if you want to. So through Jeffrey, I hooked up with the other 2 founders of the media space, and we agreed that we'd start a collaborative project to restore about as much of this as we could find. Bill Perry, in particular, was very interested in the project. In 1981, there was a third option. If you didn't have access to university facilities or $25,000 decoder, you could hand code Telidon graphics in a text editor, right? Because it's just ASCII text. Bill did that actually as part of an application package for the Bell to become a content provider for the Bell Vista field trials. So this was the result. It's actually, I'm sorry I'm showing it to you as a static image. It's even more impressive if you see it kind of drawing itself. But in any case, the adjudicators were so impressed by this that basically they gave him one of those $25,000 terminals to become a content provider for Bella Vista. And that's how Toronto Community Videotex got started. Basically, they rented a space, they rented out the equipment to artists who wanted to use it. And another interesting thing is that Toronto Community Videotex kind of still exists. They rebranded themselves in 1987, obviously, as Interaccess. They didn't want to tie themselves too closely to Videotex after that. So it's an artist makerspace now. But the significance of this is that their archives still exist, right? So that they're, for the last 20, 30 years, they've been carting around their boxes from various sites as they moved around Toronto. They weren't, when I visited them last spring, they weren't really sure what they had, but subsequently they discovered a box full of like over 100 floppy disks that are probably mostly Telidon art. So there's actually quite a bit of work to do to restore it all. What are we doing? Okay. I'll slow down. So one of the burning issues that we kind of need to address is how we're going to render all of the first generation 699 files that we've found. I mean, relying on 35-year-old equipment. I didn't point it out when I showed the thing, but when we were actually doing the film, we had to take the top off the microtel unit and blow a fan across it because it was overheating and blowing capacitors and things like that. So relying on one piece of 35-year-old equipment to actually recover these files is probably not an optimal strategy. That said, we recently discovered a second piece of 35-year-old equipment that might actually do the job too. So we're doing a little better now. That was in the collection of one of the artists who was a Telidon artist back in the day, and it's just being checked out now. But even so, there should be other ways of rendering these images, that don't rely on 35-year-old hardware. Particularly if you want to exhibit them in galleries and on the web and things like that, right? But, it's not the best way to go. So there's a couple of ways you could probably do that. The only way that I could think of that is within my grasp would be to write a conversion program. So you convert Telidon 699 to Naplix. They're similar formats. They're certainly not the same. There's a lot of difference between how they handle things. Fonts in particular are a nightmare. But anyhow, that's one of the projects I'm working on. However, this particular part of my presentation is a bait and switch, because I'm not going to talk any more about that. I figure I'm probably the only person in the world who's interested in the ins and outs of developing a Telidon 699 conversion tool. So instead, I'm going to talk about what's going on under the hood with Naplix, just a tiny bit, just to give you a sense of how the encodings sort of work. I figure that maybe 3 people are interested in that, so we're doing well. Not totally unrelated to developing a conversion tool, because you kind of need to know this stuff. So this is a blue triangle. It's actually a polygon. This Naplix doesn't have a primitive for a triangle. And the ASCII at the top of the screen is pretty much all you need to draw that blue triangle. So what I want to do is just unpack this a tiny bit. I'm simplifying a little bit here, but not a lot. Just unpack it a bit and to look at what's going on. So basically in Naplix you've got 2 kinds of bytes. You've got opcodes and operands. And opcodes are instructions, and operands are the data that the instructions need in order to function. So you can see here we have 2 opcodes, one of which is select a color, blue in this case. The other one is to draw a filled polygon. And one of the ways you can tell that something is an opcode rather than an operand is the 7th position of the binary representation of the byte is a 0. So all opcodes have a 0 in the 7th position, and all operands have a 1 in the 7th position. And that's kind of how you tell the difference, how the decoder tells the difference. And then the actual significant bits, once you get past that, are the last 6 in the encoding. So I'll show you a little bit more about what that means in terms of the polygon command. This is a page from the Naplix standard. And you can see the first, so that's the representation of the opcode that represents an ASCII 7. That's meaningless in Naplix. And then so basically just says draw a filled polygon, and then under that are all of the coordinates for the point coordinates for the polygon. So the first one is an absolute point coordinate, where you start drawing, and then you have relative point coordinates to specify the sort of vertices of the polygon there. The coordinates are actually represented as binary fractions, so that makes it possible for the display to kind of degrade nicely. Maplix, again, was designed for a whole range of display devices, from some fairly low resolution things up to devices that are, I think, higher resolution than we actually would normally use now. So it was fairly future-proof in that way, and it occupied a theoretical coordinate space of 0, 0 on the XY coordinates on the lower left there, and 1, 1 on the upper right. It was kind of cool. The last project I want to end off with, and this is trying to address how we're going to create digital online and gallery exhibitions of this work in an environment where we don't actually have a lot of the original equipment left to play with. So working on an interactive web emulator for Maplix graphics. And this touches on something I haven't really gone into too much about yet, which is that Maplix was, it was designed to be interactive. So it's very simple interactivity, and a lot of the artists didn't use it. Like, for example, Glenn Howarth, his work was basically just a slideshow, so image after image after image in a set sequence. But then other artists actually did make use of the interactivity of the display. So, for example, this sort of standard kind of menu, pick a number from the screen and then drill down through a kind of a menu hierarchy that way. This is an example of a Telidon tree structure database, actually very similar to an old school early generation website, right, where you've got the landing page and you've got your menu items, and underneath that you've got a bunch of content that's kind of all linked into specific content groups. The databases can be, and often they're stored just simply as text files along with the images. So basically showing, in the context of this image, when you press 1, it calls up this file and that kind of thing. Of course, when I'm trying to do stuff like this, I'm always sort of thinking, well, what are smarter? How does someone who's smarter than me have approached it? Or in fact, is there somebody who's already done something like what I'm trying to do? And of course, immediately spring to mind the Internet Archive and their online archive of DOS games. Of course, and specifically because they have an emulated version of DOSBox, and my stuff runs in DOSBox, in fact needs DOSBox in order to function. Seemed to be a natural fit there for doing some sort of online emulation thing. Problem was, the software I was using, PP3, really wasn't appropriate. It was an online bulletin board client, so not quite what I needed here. However, I had another stroke of real good luck, actually, similar to locating the original decoder. I got the son of the founder of MicroStar, MicroStar founder Peter Jordan, got in touch with me. He's been looking around and realized I'd been using some of their software. The upshot, one of the outcomes of that was that I became the inheritor of the MicroStar software archives. And particularly a number of programs that they wrote that never actually made it into any shareware archive, including I would say probably the crown jewels, which is this thing called MVDI, the MicroStar Virtual Device Interface Toolkit. It was, and I guess still is, a toolkit for developing interactive Videotex applications. Essentially, some code, some object code with bindings for C and assembler and BASIC that you could use to write your own applications around that required a display of Videotex. So it wasn't a Videotex display controller in and of itself, but I could use it to create one. So that's what I did on Christmas vacation using my using Microsoft C6 for DOS. So what I'm going to end off with here is just a live demo of a Telidon information package that was created by a guy named Robin Collier back in 1982. So there's just a few things going on here. It's going to look pretty basic, but it's a files recovered from an 8-inch floppy disk that were created in the first version of Telidon that have been run through my conversion program and then loaded into an version of DOSBox that's been compiled using a script and compiled to WebAssembly and running using my Videotex display controller that I wrote over the Christmas holidays. So I can't see anything that could possibly go wrong here with this demo. So I'm just gonna run this now. Bear with me while I just set things up a little bit. Okay, so this is running in a web browser, and this the old Canada Council logo kind of drawing in here. This isn't really art, by the way, but it's graphics, close enough. I'm going to just do the special programs. So it shows 5 there. Special programs, touring office, art bank, so choose 1. Then we got our fancy graphic of Canada there drawing in. So those Mercator lines or something drawing over top of that. Bit of sky. No. Let's continue on there. And that's the end of that section. I'm going to do one more section just because I really like the explorations graphic. There's a couple of things I want to point out here as well. So this is the explorations grants. This is a bit glitchy, and I have a feeling my conversion program needs a bit of work. In fact, I know it does. So you can see that it sort of overdrew the bottom left-hand area of the screen there. But this for online computer graphics from 1982, right? I mean, this stuff is not probably terribly impressive looking now, but for the time, for what it was, I think it was actually pretty cool. So a couple of other points. So yeah, you can see I've actually there's some weird stuff going on the bottom of the screen. So I've messed up the point coordinates there a bit. And sometimes, actually you can see it here, but it doesn't matter. Sometimes the text kind of jumps around a little bit, so that needs some work as well. So yeah, so that's pretty much exactly right on time, which is almost impossible. So great. I think I'm done. I just want to leave you with, well, I'm not going to leave you at this point because I didn't take your questions, but there's a whole other area around sort of authenticity of representation, right, that we could actually be talking about here. How many changes can you make to artworks and still have them in old digital artifacts and still have them be, the same or give us sort of an accurate representation of what's going on? And this is something that I've been wrestling with quite a bit. One of my sort of cop-out answers is that, well, if the artists say it's okay, then it's probably fine. It doesn't really help when the artists are dead, unfortunately. But there's a certain certain safety in that. But at the same time, there are some works that I've encountered that I haven't shown you here that are definitely like sort of pushing the boundaries of what Telidon can do graphically, and really based on some that I actually do have some curated recordings of those versus my reconstructions, and I can sort of see, the period versions are better, right? Like there's some things that I'm not capturing with the reconstructed works. In any case, that's I'll stop rambling at this point and give you a chance to ask any questions if you have any. Okay, so I'm supposed to repeat the question, and I'll try to remember to do that if anybody has any. Sorry, follow the red shirt first.
What's the theoretical maximum resolution of the coordinate system?
That's an excellent question. I can't remember off the top of my head. I'm sorry, but it's just like 16,000. So kind of getting up there. But yeah, don't quote me on that.
Where did the strange 699 and 709 version numbers come from? Were there any others?
Okay, so the strange 699 and 709 version numbers, where did they come from? They came from the CRC technical notes that were released to describe the Telidon protocol. So there was a 699E was the English version for the first version of the protocol, 699F was the French version, and then 709 for the second version. And the 709 essentially is what became NAPLIPS. Yes.
In addition to the visual representation, are the not binary, but the ASCII files themselves archived anywhere? We can look at them.
So the question is, in addition to the visual representation, will the ASCII files be archived anywhere so that we can even look at them? I mean, if you have a personal interest, you can come see me, or talk to me about it. There are some issues around what the artists will allow us to release, assuming that we actually wind up putting the emulator online, all of those files are there, right? So you'd actually be downloading the files in NAPLIPS format as part of the package that the emulator reads. So although they're not completely easy to extricate from the package, that could be done. But at the same time, yeah, I would actually like to. I'm hoping to create an online archive that actually not just has the art, but also supporting materials and the original files as well. I think that's actually really important. Yes?
Did they ever attempt to create some kind of license for the distribution of the art itself? And if so, what would the main problems that they transform that license? Like GPL type stuff.
Okay, this was of course way before the GPL was really a thing, and basically no, the way these works were displayed typically would have been one of two ways. One was during Telidon field trials. So these would have been, there'd be a central database set up, and then terminals put in places like libraries and shopping malls and things like that, so people just kind of walk up to them and access them that way. There was absolutely no sense that these things were actually going to be distributed more broadly or in any other way than that. So basically, no, you wouldn't really be accessing the files themselves. And then the other way that they were exhibited were actually on computers in galleries, so they'd be reading the files off the hard drive. And again, there was no real distribution of these things beyond the circle of artists who created them. So yeah, no, actually distribution is something we definitely have to work out. That's part of the project is getting in touch with the original artists or their estates and making sure that we have the rights to do what we're hoping to do. And so far the response has been very, very positive, but we're still early days. We're still trying to get things nailed down that way. Any other questions? Yes?
Where's the best place to get the specifications of the NAPLIPS and like the 669 NAPLIPS predecessor?
I got them from our library. So because Vivek was really involved in Telidon art production, we actually still have a lot of the old documentation in our library. Talk to me afterwards and we'll hook you up. There's no place online that provides the Telidon 699 specification, and the NAPLIP specification is still buy it, I guess, if anybody wants to. But again, there's no, as far as I'm aware, any public distribution of the NAPLIP spec either. Any other questions? Oh, hi, yes. That's a really interesting question, actually. Yes, the question is, would there be an opportunity for people to contribute their own artworks if you wanted to work, say, in this historic medium somehow? At the moment, we're looking, our project is just about restoring the historic areas. But there certainly is an opportunity for anyone who wants to use these technologies to create new works. In fact, one of the things I didn't mention is that one of the tools that's available on the Shareware archive is a tool called MGE, MicroStar Graphics Editor, which actually is a Naplix graphics creation program. It runs in DOS or in VirtualBox DOS if you want to run it that way. And it's a little bit of a clunky interface. It's not what we normally expect when we're, from modern graphic software. But it's, it works, and it could be used to create new artworks. So there definitely is an opportunity to use this, plus all of these other tools that I'm developing. And as far as possible, I'm putting my stuff online and documenting what I'm doing. So I could, in fact, create new Naplix artworks and display them in a web browser if you wanted to, or in a gallery. Any other questions? Yes, hello.
Just about Telidon itself, where did it get its most use? In the public, was it kind of like a Bell thing that they trial it out in Eastern Canada? Or
Okay, so the question is, where did Telidon get its most use and uptake? So that would be distinct from Naplix, which, as we know, is Prodigy, was the big one. But Telidon itself was mostly field trials. There was a thing called Alextel. There were, to be honest, that's a fact I don't actually can't tell you. None of these things were widely used, but I know that there were a few. Alextel springs to mind as a service that was used. That maybe had some kind of small amount of commercial uptake before it was axed, but none of these things really got much use. As I say, Naplix got a bit more. There were some actual services in the States, in addition to Prodigy. There were some other, Viewtron, I think, was one that implemented Naplix. So there was a bit more uptake for that, but Telidon itself really was mostly it was developed as a trial standard, right? It was actually, if you read the Telidon 699 spec, it says very explicitly, this is just to get things off the ground. We're not actually, this isn't the final finished version of this thing. So, or I can't be more specific. Anyone else? Okay, well, thanks very much. If anybody has any interest in this, I'm around for the rest of the day, so I'm very happy to continue to talk to anybody who wants to talk about it.
I've got the mic again, I'm sorry. Thank you. You first proposed Telidon, I said what? I realize now this is a very personal thing for you, but I've learned a lot, and your ability to do the technical work to preserve the software at home too I'm actually inspired by that, and I should be doing more of that myself, so thanks again. John?